This last type of reaction, looking for transition metal ions in solutions with, and then it gives you a few different things that you might combine with that transition metal. If you have them with ammonia, hydroxide, cyanide, thiocyanate. Transition metals can form what's called complex ions with these guys. The key thing to remember, these reactions look challenging, they look difficult, but the key here, it doesn't matter how many of them you place on the transition metal. So it doesn't matter if you combine it with 2, 3, 4, as long as you get the charge on that complex ion correct. So for example, the solution of silver nitrate added to excess ammonia. So the silver nitrate, if you're wondering where's the nitrate, it ends up being a spectator ion. Your ammonia is NH3. So if you have a transition metal, silver, around any of those other substances, ammonia, hydroxide, cyanide, thiocyanate, that it can combine together and make this weird complex ion thing. So where it says there, it doesn't matter how many of them you place on the transition metal. So it doesn't matter that this was a 2 here and here. You could have made it 3 ammonias and NH3, 3. You could have made it 4 ammonias and NH3, 4. The number of them doesn't matter. What does matter is that you make the charges balance on both sides of the reaction. So on the left-hand side here, silver is +1. Oops, that didn't really show up there. This guy's +1, right? There's no other charge there on the left-hand side. So the total charge on this left-hand side, when you combine everything together on the left, is +1. So that means when we put together those two things and make a complex ion out of them, we just have to make sure that the total charge over here, +1. This next example with iron 2 chloride being added to sodium cyanide. So we have that iron ion and cyanide. The 6, it doesn't matter. You could have made the 6 5, 4, 3, 2. Doesn't matter how many you put on there, as long as you make the charges make sense. So this guy here, so you have +2 and 6 -1s on the left-hand side. So over here, +2 and -6, this side total is -4 when you put those guys together. So on the right-hand side, we just have to make sure that our charge matches what's on the left-hand side. So here's a couple of examples of these guys. So if you put iron +3 with that SCN- ion, you could make it combine with just one of them. Well, I guess there wouldn't be parentheses there, right? If you just had one of them. It would just look like that. So now what is the charge going to be on that complex ion? Well, over here we have 1 +3, 1 -1. So this side combines to be +2. So that means this has to be +2. It's also okay if you had done something like this. 2 SCN minuses, so I'm going to make this be SCN2. That's okay also. So then what would happen here charge-wise? So +3, -2, this side's total charge is +1. So that would mean we would have to have a +1 charge over there. This guy, your zinc ion, ammonia, again, doesn't matter how many ammonias you want to put on there, right? So you could get this weird zinc ammonia ion blend So this side, positive 2 total. So that means this thing on the right has to be positive 2 total. It would be okay if you just said, you know what, I want to make that be 3 ammonias that it's going to combine with. Great, you can do that. So Zn with 3 ammonias. Sure. But over here, that's positive 2, so over here has to be positive 2.